Welcome, everyone. This is Andrea Wilkerson with Pacific Northwest National Laboratory. Thank you for joining today's webinar, Tuning the Light in Senior Care, brought to you by the U.S. Department of Energy's Solid State Lighting Program. Today's webinar is the third of a series of 3 webinars on healthcare lighting. Presenters today include me, Andrea Wilkerson, Connie Samla, and Bob Davis. I am a lighting research engineer at Pacific Northwest National Laboratory, focusing on the evaluation of emerging lighting technologies and development of lighting system solutions supporting the DOE SSL program. I will be moderating today's webinar and providing an overview of why this project was of interest to the DOE SSL program. Connie Samla will provide an overview of the senior care facility as well as present some of the outcomes from the trial installation of tunable lighting in a senior care facility. Connie is SMUD's lighting specialist working in the Energy Education and Technology Center. Connie is a resource in lighting design for commercial, residential, and industrial customers. With over 20 years of experience at SMUD, Connie develops, teaches, and coordinates workshops, works on R&D projects for new technology, as well as circadian lighting, writes specifications for SMUD programs, and designs interactive exhibits. She also teaches lighting topics to the local community via avenues like the Lions Clubs, Society for the Blind, community colleges, libraries, and community centers. Connie has a Bachelor of Science in Architectural Engineering from the University of Kansas, a Bachelor of Arts in Ministerial Studies, is a registered electrical engineer, and is lighting certified by the NCQLP. Dr. Bob Davis will present some of the measurements taken by the DOE SSL program when documenting this trial installation. Bob is currently a senior staff lighting engineer at Pacific Northwest National Laboratory, where he directs the Gateway program and leads human factors research efforts. His experience includes working in engineering and marketing at a large lamp manufacturer and leading the product development and engineering teams with a luminaire manufacturer. For over 15 years, Bob taught and conducted research in lighting as a faculty member at RPI's Lighting Research Center and in the College of Engineering at the University of Colorado at Boulder. Bob has degrees in architectural engineering and a PhD in cognitive psychology. So before I turn things over to Bob and Connie, I'll briefly discuss why the DOE SSL program was interested in documenting a trial installation of LED and controls technologies at a senior care center. Some of you may be familiar with the Gateway program, and this project was documented by the Gateway Demonstration Program, which supports field evaluations of high-performance solid-state lighting products, providing independent data for use by the lighting community. The field evaluations have occurred in locations ranging from university and airports to the U.S.-Mexico border. So for more information on the various projects documented by Gateway, you can visit the Gateway website. This field evaluation was also of interest because it included the installation of white tunable LED luminaires, building upon the research of another DOE SSL program you may be familiar with, Caliper. Caliper recently published a report summarizing photometric testing of 8 white tunable luminaires that were tested at dozens of points covering the range of correlated color temperatures. You can visit the DOE SSL Color Tunable Lighting webpage to download this report and or learn more about specifying, controlling, and testing color tunable products. This field evaluation was also of particular interest because of the aging population around the world and here in the U.S. As you can see from this figure, with the dashed lines indicating the percent of the population between the age of 0 and 24, the number of people falling into this young range is declining and is expected to decline both across the world, indicated in orange, and in the United States, indicated in blue. The solid line represents the percent of the total population that is 65 years and above. You can see that this segment of the population is increasing as a percent of the total population, and that by the 22nd century in the U.S., the percent of the U.S. population between 0 to 24 years of age will equal the percent of the population 65 years old and above. And the web page is indicated below for your reference, and this is where I was able to access this information And what's really nice about this set of data is that you can customize and select the data that you want. So if you're interested in learning more or want to be able to look at different countries, there's lots of information available, so you should definitely check that out. And back to healthcare. More broadly, healthcare is on the Radar DOE SSL homepage, and scrolling down to the webinar archives on the right-hand side of the webpage. Today's webinar content will also be made available in the same location. Now we will learn more from Connie about SMUD's participation in the trial installation of LED and controls technology at a senior care center in Sacramento. Thanks.
Thank you, Andrea. It is good to be here. Hello, everyone. I wanted to share a little bit about the company I work for to help you understand why a utility company is involved in something like circadian lighting, utilizing tunable light systems. SMUD is a community-owned, not-for-profit electric utility serving our community. We not only provide electricity to our customers, but also education on renewable energy and energy efficiency to help our customers perform and live better in their environment. But we're also engaged with our community and provide pilot projects, such as this one, to show how advancements in technology can benefit the community either in saving energy, making process improvements, or possibly enhancing a life. So let's talk about enhancing a life. Why are we focused on senior care? Well, circadian disruption often occurs when a person is placed in a nursing home, and that's basically your sleep-wake cycle. A lot of times you'll see residents sleeping during the day, maybe awake at night, and that's disruption. We want to get that back in order. Also, the average daylight exposure of a nursing home resident ranges from maybe 1 to 10 minutes a day, and actually now it's a lot of times 0 because the nurses are so busy, the nursing homes are so full, and there's just so much going on. It's actually hard to get people outside during the day, so many of them do not even experience daylight exposure. ACC Care Center is the company that we worked with, and they are dedicated to improving the lives of their residents. They truly love their residents and want to improve the location that they're at for the rest of their lives. And one more thing, we're all getting older. So if we can go into these places now, maybe make some improvements, by the time we get older, maybe some of us, would be in a nursing home, it might be a better environment. When we're young, we can see just about anything. Many of us have perfect vision, and it's great, but as we age, things happen, and this is a natural progression that all of us experience. Our pupil becomes smaller, almost fixed in size. Less light enters the eye, and it's difficult to adjust to changes in brightness. For a senior, we're specifically talking about during this webinar, they a lot of times might hurt their eyes if they go from dark to brightness. But more importantly, when they go from a bright environment to a darker environment, it might take 30 minutes or more for them to fully adjust and have night vision. So a lot of times that's when falls might occur. Also, our lens thickens and becomes slightly amber in color. You can see on the bottom left, there's a lens of a 10-year-old, and on the right, a lens of a 65-year-old. The 10-year-old is clear, it is thin, and it's beautiful. But as we age, and again, this is natural progress, that it becomes cloudy and it becomes thicker. It's difficult to focus when our lens thickens. We absorb the light. We can't utilize all the light that is in our space, cancels out the blue range, and it causes light to scatter within our eye. So these charts here, the information is taken from the Illuminating Engineering Society, and it just demonstrates basically that we need more light as we age. So if you picture the room where you are at right now, look around and look at the lighting that is in your space. If we are 20 to 25 years old, we are able to utilize all that lighting in that space. But as we get older, we are not able to utilize all of that because of our lens and how our eyes have aged. If we're 50 years old, we're able to use about 60% of that. And then if we're 80 or above, maybe only 20% of that light in that space. So I always love to tell people that my 90-year-old mother-in-law lives with me, and I have to remember that she can only utilize about 20% of the light in our home, Whereas it might be too bright for me, it's comfortable for her. And as we'll see, the seniors care facility here, the age of the residents was over 80. So we need more light as we age, but also we can't tolerate the glare as much. So if you're sitting at a window and you look out and maybe there's a car there and the sun is hitting the car windshield and coming into your eyes, that's glare. And it's not comfortable. But when we're 20 or younger, we can tolerate that. But the older we get, it's less tolerable. It hurts our eyes. And if you look at this chart here, when we're about 80, we can only handle about 20% of that glare that we could when we were younger. So overall, we need more light, but we want less glare. So how do we achieve that? Well, then we factor in eye diseases. So these are pretty common. So yes, we need more light. We don't want the glare. 50% of the folks ages 65 to 75 years old experience cataracts. You know, there's glaucoma, macular degeneration. This one is increasing. It's forecasted that 3 million people will have macular degeneration by the year 2020. And then, of course, the bottom picture there is if you have diabetes, then this is one of those diseases that you could actually get then. So you factor in eye diseases and the fact that we can't see as well and we don't like the glare. This is kind of interesting. So yes, seniors have very specific lighting requirements, and the existing lighting in these spaces, these care centers, often is inadequate. If you see the picture there, courtesy of Center of Design, you can see in the foreground that there's indirect lighting, so that's good. There's no glare on the luminaires, but there's not a lot of lighting in that space. And as a senior, they're only going to be able to utilize about 20% of that. In the background, there's beautiful doors and daylight coming in, but that's glare. So this is not a very good environment for a senior to be in. Lighting can have a huge impact upon people, and I think you'll see that throughout the talk today. And the sector is long overdue for a lighting makeover. A lot of these buildings are old. They've used state-of-the-art technology 30 years ago, but now we have some great technology that we can utilize for them. So the project is SMUD partnered with the Department of Energy, the Gateway Program, manufacturers, and our local nursing facility, ACC Care Center, which is Nursing and Rehab Center, specifically to test two things: tunable white LED lighting systems, circadian lighting for basically 24 hours a day. That's what we were testing, and also indoor night lighting options for safety. The ACC Care Center, as shown on your right, is basically a very prominent nursing home, 5-star rated facility. And on the very right-hand side of that picture is the entryway. In the center is the nurse's hub. So you kind of see it as a spoke on a tire. And the nurse's hub can look down every hallway. The average age of the resident in this facility is 87 years old, and they're all wheelchair bound. 2/3 of the current residents have been diagnosed with some form of dementia. So we felt that this was a great application to try circadian lighting. The project goals: we wanted to investigate different lighting techniques and applications for their upcoming remodel and addition. If we go back to that top right picture, you can see that that's a spoke on a wheel, but what they're going to do is they're going to fill in the ends of those hallways and connect them. So that's the addition. It's going to be all connected there, and then they're going to remodel every bit of their rooms. And what we were trying is lighting techniques and applications and concepts. We weren't necessarily trying new luminaires and light fixtures. We were looking at the concepts and what it can do for this space. So we wanted to explore the potential benefits and challenges of circadian lighting. So could we improve the lives of at least 3 residents and enhance the nursing staff experience? So let's look at the technologies existing and used. So we relit 2 rooms. One had 2 residents and one had 1 resident. And this is the existing lighting. Pretty typical of 1 fluorescent over the bed luminaire, 2 lamps. There's one that's directed downward and the residents can control that light, and then there's one directed upwards. And that is very typical in many facilities. We see that all over where we go. Now, unfortunately, this lighting is not adequate enough for what they need to do, especially if the doctor needs to look at legs or feet or install a catheter or something like that. In one of the previous webinars, we heard that the nurses sometimes will have to bring in flashlights to augment the lighting because there's just not adequate lighting in there to do what they need to do. In this photo, it's during the day, and there's actually a window on the far left. I cannot see, but you can see it is a little brighter in that space. So this is existing, and this is pretty common. What did we do? Well, we wanted to replace the over-the-bed luminaire with a white tunable luminaire, but we could not find one. Now, this took place last year. We looked all over, and we could not find one at the time. I'm happy to say there are some available now, which is great. But what we had to do is we had to make our own. So basically, we took tunable white cove lighting and put it inside a white plastic gutter, and it was aesthetically pleasing because we wanted to make sure that was good. But at first we wanted to put it in the ceiling, but there was no room because space in these rooms is taken. There were sprinkler heads, there were monitors and sensors all in the ceiling, so we couldn't mount anything to the ceiling. So we needed to go to the wall space. And we were able to put this cove on 3 of the 4 walls, but not all the way around like we wanted to, just because of cabinetry and all sorts of things. So they basically got these LED cove lights inside this gutter, and we commissioned them per the Lighting Research Center protocols. The Lighting Research Center actually has a Light and Health Institute that I was able to attend, and they've done a lot of studies on nursing homes. And they actually had a protocol that we followed for this room, and I'll show you that in just a moment. We also replaced the over-the-bed light with a new LED, and this one's nice because that top part where the arrow is actually rotates up and will illuminate all the way down to the feet. So this provides adequate light for the nurses to do whatever they need to do. So that was really helpful. And then at night, there was a little chart light that the nurses could use in case they needed to read something and not turn on the overhead lights. So this is what the rooms looked like. And this is, again, the protocol from the LRC. From 7 a.m., lights are on. And these residents had a schedule already. So at 7 a.m., the lights come on. And from 7 to 2, it's 6,000 Kelvin in their room. And it doesn't come on abruptly. It comes on about 30 seconds. There's about a fade time there. And it's on for that long at 6,000 K. And then from 2 p.m. to 6 p.m., it's just more of a white light, not so much of a blue light, just a nice, clean white light there. And then from 6 p.m. to 8 p.m., it changes to 2,700 Kelvin. And lights out at 8 p.m. So these residents, from 8 p.m. to 7 a.m., lights out in their rooms. And most of them go to sleep at that time. If they need to be awake, then they'll go back into the corridor. And then, of course, there was a nightlight option in case the nurses needed to do something, in there. So 6,000 Kelvin, 4,100, 2,700 Kelvin was pretty much the colors that we chose to get the proper circadian stimulus. We also installed night lights in this room. And again, we looked for under the bed, amber, night lights, and we really couldn't find any. So we made our own. So all the technology I'm talking about today is LED, and these were LED rope lights, and we put them on motion sensors under the bed. And it was in a U shape, so wherever the resident decided to get out of bed, that motion sensor would pick them up and immediately turn on. And this was actually a big hit. So this was in one room. In the other room, we wanted to try a different concept. So we had low-level lights about the size of an electrical outlet installed in the wall, and those were on motion sensors as well. Now what's interesting about these two concepts is there's pros and cons to each. The first one we really liked because it outlined the bed. There were no hot spots or anything like that. But when somebody comes in and cleans, they unplug it and sometimes forget to plug it back in. But at least it can be plugged back in. On the bottom picture where the lights were installed in the wall, Again, real estate is at a premium, and every time we came back, we found a chair or furniture or something moved in front of that. So it didn't work as great as we had hoped. Also, this one in the wall provided a little more brighter hotspots than the other one, and at dark, it was actually a little too bright. So just lessons learned on that. Both are good concepts for different applications. In the restrooms, we had basically, technical term, glary globe on the ceiling and a glary luminaire over the vanity. This, again, is pretty typical and pretty self-explanatory. What did we do? Well, we removed the glary light fixtures for sure. And we replaced the existing mirror. We took out that mirror and replaced it with LED integrated lighting in the mirror itself. And we put it on a dimmer because what we found out at least a year ago is that it was too bright. There was too many lumens coming out of that mirror and it needed to be dimmed down. So that was a good thing that it was on a dimmer. There's good products out there now that actually do change color as well. On the ceiling, we replaced the globe with a surface-mounted, basically a wall sconce that could be mounted to the ceiling, and it has a nature scene with leaves because that complemented the theme of the ACC Care Center. They're very much into nature, love nature, and this was just a great, soft, delicate, and nice-looking fixture for that space. But this was the big hit, replacing the existing handrails with new handrails with amber LEDs controlled by a motion sensor. Because most of us probably know that the falls occur after leaving the bathroom back to the bed. Because once you get out of bed, we're pretty much dark adapted. We can look and see where we need to go. But if an overhead light has to be turned on at that time, then it bleaches out our rhodopsin and we lose our night vision. And once we do that, especially at age 87, it will take 30 minutes or more to gain our night vision back. So this type of lighting here was enough lighting for the residents and the nurses to see what they needed to do without turning on any overhead or vanity lighting. And it didn't bleach out their rhodopsin, it didn't stimulate their circadian system, and was enough light for them to go back to their beds safely. In the hallways, we had 4100 Kelvin, 2-lamp fluorescent wraparounds or luminaires. And this, again, is pretty typical. So wherever you're at, if you're sitting down, you would be about the same height as a wheelchair. And if you look at this picture, put yourself in that hallway. If a nurse comes up to you and you look up at the nurse, what is also in your field of vision? We have a very glary light fixture. So some of the residents would not look up. And I think a lot of that is because that was too glary. It hurt their eyes to look up at a nurse because, again, they're all wheelchair bound. So in the hallways, it was really nice because we were able to replace the fluorescent luminaires with a tunable white luminaire, 1-for-1. If you look on the right-hand side of this picture, there's the existing fluorescent fixtures. On the left, we have the new tunable white luminaires that were actually dimmed down and changed to 2700 Kelvin, a really warm color at night. And you can see it's night because if you look all the way down that hallway, there's a door and windows and it's very dark outside. So this is the color at night, and it was nice because you can see this image of very comfortable lighting on the left versus existing lighting on the right. What we did also is we put them on automatic controls for dimming and tunability. So let me let you see what that looks like. So from 7 a.m. to 2, they were at 6500 Kelvin, dimmed down to about 66%. And it appeared, we were basically simulating daylight. That was the hope here. From 2 p.m. to 6 p.m., 4000 Kelvin, dimmed down to about 66%. And then from 6 p.m. to 7 a.m., because these are on 24/7, it was dimmed down to a warm 2700 Kelvin at 20% output. And needless to say, we saved over about 65% energy just in this one corridor. So I want you to experience this. Again, you're in a wheelchair, you're looking out down this hallway. So from 7 a.m. to 2 p.m., you get more of a daylight feel. From 2 p.m. to 6 p.m., it's just bright white light. And then in the evening hours, it's a warm light, plenty of light for the nurses to see. We worked with them, and this was enough for them to see and experience.
So now it's my turn to tell you a bit about the results of the study. This is Bob Davis. DOE was really excited to partner with the folks at SMUD on this project. As Andrea mentioned, we're interested in the tunable technology. We're interested in the healthcare application. And we're also really interested in this sort of emerging understanding of not just the visual effects of light, but also the non-visual effects of light. So this project was exciting for all those reasons, and we are really grateful that Connie and her colleague Dave Bisbee at SMUD invited the Gateway program to take a look at the project with them. Before I start into the results, just remind everyone tuning in today that you can type in questions at any time. And so if you want to start putting together questions even about the technologies used and the types of things that Connie has already covered, don't wait till the end. Better if you can type them in now, and we can begin to get those processed and get them queued up for the question and answer at the end. The other thing I wanted to let you know is that Melanie Seeger, who is the administrator of the ACC Care Center facility, and who was the one that was really the driving force behind the trial installation. Melanie is on the line with us today as well. She'll be available during the question and answer. And so I know from the attendee list that we do have some folks who are working in the healthcare industry and healthcare facilities. So if you have any questions that you'd like to know from the facility standpoint and the administrative staff at the facility, feel free to enter those in as well, and we'll have Melanie be able to respond to those when we get to question and answer. So let me start the results by saying that part of DOE's role here was to evaluate the general performance of the system. You all know, I think, the Department of Energy is focused on energy, and we're focused on performance of solid-state lighting. We are not light and health experts. Connie mentioned that she and Dave had attended the Light and Health Institute by the Lighting Research Center. We're implementing some of those protocols. You'll hear towards the end that there's also a doctor at the facility who was very interested. And so we were comfortable getting involved in this project where our role was really to focus on the technology, understand the performance, and knowing that a lot of the folks on the webinar are from the lighting industry, but we know that there are some folks in healthcare who may not be as familiar with the newest things in kind of the lighting research world. So we are going to talk about the results from both the visual and non-visual effects. And with this illustration, I just wanted to sort of talk about those two different ways we look at lighting today. That we know that from the back of the eye, there is a pathway shown in yellow here from the retina that connects directly back to the back of the brain, the visual cortex. You have rods and cones in your retina, which are the photoreceptors that actually sense light. Those rods and cones connect to the visual cortex through a layer of cells called the retinal ganglion cells. And up until about 20 years ago, what we knew about the retinal ganglion cells was that they carried this visual information, this information about light from the rods and cones, back to the visual cortex. And so all these things we do that depend on vision, on us seeing things like writing and reading and watching things and communicating with each other visually as we're trying to learn in classrooms, all the things listed here depend on vision. And that is usually linked to how much light is available, what's the condition of the visual system. So I want to start by sort of following up some of Connie's comments about these older facilities that we have in senior care and in most of the healthcare industry, where current light levels are often below current day standards. And so our role here was to come in, very carefully document the illuminance levels and some other characteristics of the rooms. And so Connie mentioned the one double room. This picture actually lets you see the window location. Under the fluorescent system, and again, that fluorescent wall-mounted luminaire is just above the bed. It's not on in this picture because of the daylight. But when we looked at the general ambient level of light across the room, the horizontal illuminances, it was about 95 lux. Those of you who think in terms of foot candles can divide that by 10 to get the foot candles. So under 10 foot candles. And then we wanted to see what's, at the center of the bed, what's the horizontal illuminance? As Connie mentioned, we had nurses and some of the caregiving staff who said, sometimes if we come in to try to look at a wound on a leg, it's really difficult to see. And so we documented, under 200 lux horizontally. And we also wanted to look at, if you were trying to sit in bed and read with that light, how much illuminance would you have vertically on the reading material? And that was under 400 lux. Again, with the average age of 87, these illuminances would not be considered really adequate today when we look at the IES recommendations. With the LED system, we took 2 sets of measurements, one with just the wall-mounted fixture on, and then separately with the cove. Those would just add up if both systems were on. And as you can see, we won't go through the details here, but you can see that the illuminances were significantly increased in order to better provide for the visual needs of the caregivers and the residents. So for reading the vertical surface, for kind of looking at the extremities on the body down towards the center and bottom of the bed, much greatly increased illuminances. Now we're the DOE, and so you might say, boy, to take one fluorescent luminaire and replace it with this LED and bump the light level up so much, not a strong energy story, and that's true. And that's what we realize is going to be faced in many healthcare applications, that it's not just about the energy. We have to get better lighting in these facilities and have to see how we can better meet the needs of the people in the facilities. And hopefully with solid-state lighting, we can do that using more efficient technology. I'll move on to the single room. And I meant to mention that the Gateway report is already available. If you haven't accessed that yet, you can go to the Gateway website. We have a full report. SMUD folks also have a report on their website. So we're just giving you sort of the quick overview, but there's a lot more details available in the full reports. You can see here in the resident room, for one person, I showed 2 ambient levels here, and part of that is because if you look at the photograph, that area on the left of the photograph where the doorway comes into this entry area, and then what you can't see there is just behind the curtain is door into the private bathroom. But that area really had no light in it at all in the existing installation. Usually the door would be open, and so there would be more light there than is shown here. But we wanted to characterize that. So the ambient 1 is sort of a measurement of ambient light that comes in a line from the doorway down to the foot of the bed. And ambient 2 is more typical of what's out here by the bed. You can see, again, less than 10 foot candles, less than 100 lux. Looking at the bed levels, pretty similar to what we found in the double room. Similar type approach with the single fluorescent luminaire. And then converting those over to the LED, again, much higher light levels, much more appropriate given the age of the residents and also the needs of the caregivers for taking care of the residents when they're in the bed. So from a visual standpoint in the residence room, really great improvement in the light levels. I think you can see from the pictures too that just the overall sort of ambiance in the room, much more in a reflected light because of the cove. So you can see even in that ambient 1, didn't really add any luminaires out in that entry area, but just the inner reflected light filled in that entry area much better. Bathroom, same story. As Connie mentioned, replacing those compact fluorescent globe-type fixtures with an LED fixture greatly increased the illuminances. And this picture shows the rail light. That was not measured as part of the illuminance here. We have that on in the picture just as an illustration, but the illuminances here are strictly from the LED lighting. And again, in the report, we go through the mirrors and all the different areas to show those comparisons. So overall, at a high level in the resident rooms, just great improvements in the amount of light available, which is important for this application. We did want to talk some about the non-visual effects. Connie mentioned that circadian lighting was a big part of what the goal for the ACC project was. And so let me mention a bit about what we're learning in the non-visual pathway. Again, we talked about those retinal ganglion cells before. What the blue path is showing is that what we've learned really just within the last 20 years is that some of the retinal ganglion cells actually are photoreceptors. They sense light. Those are called the intrinsically photosensitive retinal ganglion cells. So those of us that have been working with this in lighting have adopted this phrase IPRGCs. The IPRGCs connect not to the visual cortex. So they sense light, but they don't send a signal to the visual cortex. They send a signal to the hypothalamus. The suprachiasmatic nucleus is part of the hypothalamus. And that light doesn't help you see things, but it controls other biological effects, or it influences other biological effects. The main ones that we've been talking about within lighting are the effect of this non-visual pathway in suppressing melatonin. Most of you are probably familiar with melatonin. You can buy it at a drugstore. Something that helps you sleep. Your body naturally produces melatonin in the evening and at night. We call it the sleep hormone. And things like alertness and cognition can be affected through this non-visual pathway. I have a little box on here that says photic and non-photic. That's just sort of a reminder to myself and to all of us that we know that light influences these non-visual effects, but we also know there are many other things that aren't related to light that are happening in your body that can affect these as well. So light is part of it, but not the whole equation. How does that map onto this project that we're talking about now at the ACC Care Center? How can we sort of characterize what's happening non-visually? You know, we really want to try to characterize the whole stimulus differently. But this slide is showing, if you look along the bottom, it's showing the wavelengths of light. And this vertical axis where it says relative absorbance is simply saying, for the different types of photoreceptors, which wavelengths of light do they detect the best, if you will? We know from the visual standpoint that we have rods and cones. So the black line on here shows the characteristic response of the rods and the wavelengths that the rods respond to. So the peak there, a little bit over 500, between 500 and 550 nanometers is the peak rod response. With the cones, you have three different types of cones. They're often abbreviated in medical journals and scientific journals as the short, medium, and long, meaning which wavelengths they respond to. More sort of commonly and less rigorously, we sometimes call them the blue, green, and red cones, but they really are defined based on their response to different wavelengths, and that's shown here. And so those rods and the three cones sort of add up to produce our visual response. Most of you have heard of the V lambda visual response curve, and we can characterize our light stimulus using V lambda, and that's how we define the lumen and the foot candle and all those metrics. But now the question has become, well, what about this non-visual response? How can we characterize what's happening with our non-visual response? And so the recent research has helped identify what is the wavelength response of these iPRGCs, these cells that connect to the hypothalamus and that really seem to influence the melanopic response and the production of melatonin or the suppression of melatonin. Right? Your body naturally produces melatonin at night, and what we've found is that light that particularly stimulates the iPRGCs, as well as the other receptors, can help suppress melatonin production. So for example, if we take a LED fixture, and this is data based on the ACC fixtures, a 2700 Kelvin LED fixture. What's shown here is the response it would produce if we calculate based on its spectral power distribution for each of the types of photoreceptors. And so this one that's circled shows what the melanopic response would be just looking at the iPRGCs, not taking into effect any other combinations, just the iPRGCs. And we can compare that then if we tuned the LED fixture to 6500 Kelvin, and you can see you'd get a much bigger response through the iPRGCs then. We believe that then could suppress melatonin. Right? We're not measuring melatonin at all here. We're just looking at the spectrum of light and the response of the iPRGCs. So Connie mentioned these amber rails, and that's kind of an interesting one to look at because if we take its spectrum and plot it this way, we find very little stimulation from amber, these particular amber rails in the iPRGC channel. So the idea here is if a person wakes up at night and needs to go in and use the bathroom, with the old system they would have had to turn on these bright, glary, compact fluorescent fixtures. Now with the motion sensors, these lights are on automatically when they get out of bed. They're not going to suppress melatonin, hopefully not be as disruptive to the sleep cycle because of the spectrum of light that's being produced there, as well as the lower level intensity. So the question then is what kind of metrics can we use to start to characterize this new understanding of these non-visual effects? And there's a couple metrics that are being talked about in lighting. The one we put in our report for this project is something that's used in a new standard for buildings called the WELL building standard. It's sort of like the LEED rating system. It's a rating system primarily for offices. But based on that reference I had in previous slides, a paper from Lucas and others, they had proposed this equivalent melanopic illuminance, or specifically equivalent melanopic lux, EML, you'll see it abbreviated. And the idea behind this is if we know that photopic illuminance, or that V lambda based illuminance, is based on that response of the rods and the cones that we call V lambda, if we know for a certain lux level, so in this chart it says at 100 lux at the top, we know the 100 lux is photopic. If we look at the spectrum of different light sources, how much melanopic illuminance, in other words, how much stimulation through the IPRGC channel is being produced. And so we've just listed some of these values here. For the fluorescent 4100K system like they had at ACC, 61 melanopic lux for every 100 lux of photopic. I put the 4500K LED next since that's kind of the closest match to the fluorescent. A little bit cooler, and also with LED, a little more of the short wavelengths in it. So the melanopic lux at 100 lux photopic was a little higher. But the important part here is if you shift to that color temperature, 6500K, right, you've bumped it up to 98 now, more than the fluorescent was. If you go down to 2700K, it drops down to 43. If you use amber, it drops down to 11. Now, you would never use an amber nightlight to produce 100 lux, and so that 11 is at 100 lux. It would go down even lower based on the intensity. But the general idea is you get a sense for how much more or less stimulation a particular spectral power distribution of light might be producing in the IPRGCs. So that translates into this project where we looked at the corridors, for example. And as Connie mentioned, in a corridor, you want to not only worry about the horizontal level, we looked at the horizontal level average illuminances down the corridor, but you also want to know what are the vertical levels at the eye. And so we had measured with the fluorescent system about 120 lux average vertical at eye height. When you convert that to melanopic to see what the response might be in the IPRGC channel, you get 73. And then when we looked at the LED system, we were able to look at the morning setting, as Connie mentioned, 6500 Kelvin. Now it turned out that because it's tunable, they found with this system they didn't have to run it to full intensity. They could save some more energy by keeping it down, even dimmed a little bit during daytime hours. You can see it dropped the light levels a little bit. In that case, the light levels in the hallways were beyond IES recommendations, and so they were able to kind of harvest some energy savings by tuning it down a little bit. But even at that lower light levels, you see the vertical average photopic illuminance went down to 100 lux, and yet the melanopic illuminance is higher than it was with the fluorescent. And then when we go to the nighttime setting, they moved to a warmer source, as shown in the picture on the right, 2700 Kelvin, and it's also dimmed down to just 20% level. And so that really drops the melanopic content. And so again, the idea here is in the morning time when people are out in the hallway, you want to give them, stimulate the IPRGC, suppress melatonin, sort of help announce that it's morning. And in the evening, at night, if someone's out in the hallway, we want to avoid that type of stimulation. Now, you might be saying, so what do these numbers mean, really? Equivalent melanopic lux, some of you may have heard of the circadian stimulus that the Lighting Research Center has been working on. These are metrics that really kind of are trying to characterize the lighting stimulus and the different spectra, and also link it to the human response. Like any metric we have, whether it's a color metric, a glare metric, a flicker metric, the question is how do we characterize the stimulus and then link that to the human response some way. And so a lot of us are wondering what these numbers mean, and I can tell you that to me, we don't really know what the numbers mean yet. Right? I wish I could give you a good answer for that, but it's an emerging area of science, and we're all still trying to understand it. So we can calculate these metrics. What does seem clear from the papers that have been published is that there are 5 different factors, at least 5 different factors, that affect our response to these stimuli in the circadian realm. I've talked about the spectrum, the SPD, the spectral power distribution, and the intensity level. So the EML, the equivalent melanopic lux, takes into account spectrum and intensity. But we also know that the duration of exposure is important, and EML doesn't tell you anything about that. The circadian stimulus metric that the Lighting Research Center has proposed is based on a duration as well. And so it's accounting for each of these three. We also know that the timing, specifically when it happens in your natural sort of sleep-wake cycle is important. We know that a lot of things about the individual affect this. And so right now we can calculate the circadian stimulus levels. There's an online calculator from the Lighting Research Center. We can calculate the equivalent melanopic lux. There's an online calculator with that Lucas paper I cited earlier. But we're still trying to understand how do those link to human response. And so as we're continuing to do this research, at some point, hopefully, these will become adopted into things like recommended practices, but we're probably still a little ways away from that. In the meantime, from DOE standpoint, we want to at least provide the information so you can see the metrics, see how they're changing. Now, in terms of the human response in this project, there were some pretty interesting findings. In a field study, you never know exactly what all is happening. You never know exactly what's causing them. But at this point, I want to go back to Connie and let her tell you about some of the outcomes that the ACC folks have noticed in their facility. Connie?
Thank you, Bob, very much. I think you said it well, that it's still an emerging area of science, but it really does come down to what happened to these individuals. And this is actually my favorite part to talk about. So with these night lights, was there a reduction in falls? Well, there's a quote here from the ACC administrator, and I'm just going to read this because it's so powerful. The quarter before the lights were installed, we had 5 falls on Cherry Lane. The quarter after installation, the number reduced to 3, but more importantly, there were no falls on Cherry Lane in the last 3. That is huge. If you're an administrator, if you're a nurse, if you're a senior yourself, you know that you just don't want to fall. That can be detrimental. So that was a great finding. And I just spoke with the administrator this morning on just getting more information, because that was several months ago. And in the last 5.5 months, the fall rate has been definitely lower. And there was one high fall risk resident that moved onto Cherry Lane, and in the last 5 months, this resident had had a 240% reduction in falls since he moved to Cherry Lane. So something's working on that lane, and it's quite remarkable. There's other outcomes here. The residents are sleeping through the night. Now remember, we only worked directly with 3 residents. We relit 2 rooms. They are sleeping in their beds. There was one resident who would only sleep in a wheelchair, and now he's sleeping in his bed. Can you imagine the better quality of sleep that he's getting now he's in his bed from the wheelchair? They love the night lights. Those night lights bring a sense of security and safety, because when they go back to their bed, there's some light that is on. They never have to guess, is there something in my way? Am I going to fall? You know, what's going on? They have a sense of security now with the night lights. There's also been a reduction in psychotropic and sleep medications. So that alone can save money, and that's just a good thing. In dementia patients, there's certain behaviors. Certain ones are yelling, agitation, and crying. And amongst these residents, there's been a 41% reduction in these behaviors. So consider a resident who's yelling. That affects the resident and the nurse and the whole center, really, because that just has a ripple effect all throughout the center. And when there's a reduction in that, then the nurses don't have to deal with that. They can go deal with other things that they need to be doing. And that was just a really great thing to see. And in one particular resident who had dementia, he had a 71% reduction in behaviors. So 71% reduction in the yelling and crying and agitation. Granted, there was only 3 residents that we directly worked with, but if that was your loved one, if that's your family member, the quality of life has just been increased. Just amazing. Other outcomes, other residents are hanging out in Cherry Lane. You know, for all those residents that live on Cherry Lane that did not get their rooms relit, it's funny because they are going out into the hallway. Because a lot of these residents, they just kind of sit out there and everything, and they're gravitating towards this hallway, and they're actually sleeping better, because a lot of times those doors are left open at night, and the nighttime lighting would go, bleed right into those rooms, and now it's dimmed down, it's a warm color. They're actually getting the benefit of just being in that hallway. That's been such a big change that the administrator is actually looking into replacing all the lights in the hallways, even before their main remodel, because of the, just the results that she has seen. The nurses are embracing the new lighting. And what's great is at the nurses station, they were educated on how to use the controls so they can dim the lights and they can color tune the lights. So they can change it from 2700 up to 6500 Kelvin. And how they're utilizing this is in the evenings. There's 3 shifts because they're there 24/7. In the evenings, they are using it to help stimulate them, right? 6500 Kelvin and helping them stay awake. It's kind of like us taking a walk outside in the daylight. We become awake and alert and, just better for that evening shift. We've also heard that there was a reduction in coffee. So people aren't drinking coffee as much at night, so that's a good thing. But also the nurses will use these lights when a resident comes out to them in the middle of the night and speak to them. They can dim the lights down, they can change it to 2700 Kelvin and actually help calm that resident down, and hopefully that resident would go back to bed quicker than they used to. At ACC, there's an attending physician. He's very involved with the residents, loves them dearly, and he actually prescribes daylighting for them. He recognizes the value of daylighting for each individual, and he will prescribe daylighting, which is wonderful to have him involved in this. The best thing about it is he's taking this information to the medical community. So as a lighting designer, I can do so much, right? I can take this to our circle of influence and everything, but to have a doctor take this information to the medical community and speak doctor language and talk about the importance of this circadian lighting in this facility, other doctors will listen to him. So that's just been a blessing. And then family members and new staff are being educated on what is circadian lighting. And what's nice is we were able to relight the administrator's office. So she is our advocate. When somebody new comes in, she speaks to them and she educates them on what type of lighting it is, what it has done for the residents. And many of them have actually asked when their loved ones are going to receive the new lighting. So what I want to do is just end with this quote. And I think it speaks for itself, but I am just going to read it. ACC will be incorporating many of the lighting solutions piloted in this project as best practices in terms of fall risk, sleep enhancement, and non-pharmacological approaches for behaviors related to dementia. Thank you.
Thank you, Connie and Bob, and welcome, Melanie. We appreciate your efforts in this research as well. We have received actually quite a few questions during your presentation, and I know that we definitely will not be able to get to them all, but hopefully we can, at a later date, post some responses to some of these really good questions on the DOE SSL website, and we would, of course, let you know about that as well. So let's go ahead and get started. Bob, you're first up, and there were several questions related to an increase in the consumption of energy between the fluorescent system and the new LED system, and just wondering if there was, and was there any energy savings?
That's a good question, and obviously something we're curious about going into it, and I'll let Connie chime in as well. I think from our standpoint, the hallways, the savings is huge. The hallways were pretty much 24/7 on full with the fluorescent system, with the caveat that the nurses had learned often they would switch off half the fixtures at night to try to be less disruptive for the residents because the doors are left open. And so when we did the calculations for the report, we looked at the fluorescent system with the assumption that sometimes they were switched off at night. But that full power whenever they were on, compared to this LED system where it was, like I said, dimmed down at about 2/3 for most of the day and then dimmed down to 20% at night, they saved almost 70% energy in that hallway. And I think most of us know the energy used in corridors is a major part of a facility like that. The resident rooms, frankly, we could look at the connected load in that. We didn't do any energy monitoring in these. We were trying to be as non-invasive as we could with the facility since it's continued operation. So to be honest with you, we don't know exactly what the energy story is because some of the systems are controlled by the residents, and we just aren't monitoring exactly what's happening. But certainly from a connected load standpoint, with just having 4 fluorescent lamps in the room before and going to the LED system, from a connected load, it's equal or greater with the LED. From an energy standpoint, with increasing the lighting in that, I would guess it might be about the same. It could be a little more, but we don't have a detailed analysis of that. And Connie, I just don't remember if SMUD took a different look at that or.
Well, yeah, I just want to remind everyone that we were testing concepts at this time. Our goal was to replace the over-the-bed luminaires with a white tunable light, but we didn't have any at that time, so we had to make our own. But the goal would be just one-for-one replacement, and anytime you replace incumbent technology with LEDs, you're instantly going to save energy, and then if you can dim it down, you're going to save more.
And Connie, back to you. Were there any complaints among patients or staff when the hall lights were at 6,500 K? And then also, Melanie, feel free to respond as well and comment on any patient and staff response.
Yeah, good question on that. We actually did end up dimming them down a little bit because LEDs can be intense. But we worked with the nurses on this, and we ended up dimming them down to 66%. That was the sweet spot.
Melanie, do you want to comment on just in general patient and staff response to the new lighting? Connie did a nice job summarizing it, but
I'd love to. You know, the overwhelming response has been so positive with both the residents and the staff and the family members. In fact, my biggest question now is when are we going to get the lighting on our other 3 neighborhoods? So overwhelmingly positive response to the lighting changes.
And Connie, how did you choose the color and timing for the lighting changes?
Okay, so going back to the Lighting Research Center, the Lighting and Health Institute, they had a protocol that they wanted a certain amount of circadian stimulus during, the waking hours. So that led us to the different schedules that we have, and I can give you more information on that because there's lots of numbers and all sorts of things on that, but that directly came from learning about the protocol and just changing it for this facility.
And Connie or Melanie, you might be able to comment on this as well, but there's a question about how much patients or how many patients typically receive some sort of daylight exposure, and they'd commented that there seemed to be windows in the room. So I don't know if you have any further explanation in that regard.
I think our facility is fairly typical at this point. It was built 30 years ago, and so, of course, every room has a window. And there's some daylight that comes in, certainly. We do try to get residents out on patio areas and then out in the, we have like a park-like setting in the back. But still, the amount of time that people spend inside versus outside is not what we would typically experience walking around and just being outside, conducting business and in our daily lives. So this has really made a difference with the residents that don't get out as much, I think.
Okay, and with that, we're a few minutes over, but I just want to thank you for participating in today's webinar brought to you by the U.S. Department of Energy Solid State Lighting Program.